Another new week and another new proposal. Welcome to Peep and EIP, an EIP-focused talk with the author of a proposal to understand why we need that as a standard. I'm your host, Pooja Ranjan, and today's guest is Giuseppe Bertone. We are going to talk about EIP-2848, My Own Message. This is basically a standard track ERC created in August this year. So it's like straight out of the oven proposal, recently added as a draft and is looking for your attention, available to help with your project. So without further ado, let me pass it to the author. Please let us know a little bit about yourself and then we'll dive into the proposal.
Okay, so good evening to everybody. I am Giuseppe Bertone. I am a developer and tech enthusiast since 20 years now, and I'm building in the space since 5 years. So I develop in Ethereum, Bitcoin, and also bad blockchains like Corda and Hyperledger Fabric, but for work. So I'm like to try to participate in the community. So I filed many PRs to clients like Ethereum, Parity, and so on. And I'm still learning, and I like to achieve some result in this field. So you can find me around the web in many places like GitHub, LinkedIn, Stack Exchange. So if you want to contact me, don't hesitate, and that's it. So I can start with the why. So since the why I try to do this standard. Essentially, I think that we must start from some pain points. So I think that sharing ideas and opinions, it's still difficult to be done, and it is still very dependent on centralized services. So this kind of dependency led to some unreliable ability, some non-censorship resistant services, and lack of a single source of truth. And another thing that I find very difficult to achieve is understand when a message comes from a specific author, and essentially it is updated, and it's not some not valid anymore message. So the word trustless, I hope that I want, is a word where as a developer, I can easily talk with my user base. That is not the case actually now. And I have control of my reputation. So when I say something, I want the others understand that it's said by me, and it's not something modified in any manner. And as a user, I want to easily verify these kind of things, and I want to easily share my thoughts, even not as a developer, maybe as a journalist or an author or anything. And I want to control my content. So I don't want other platforms to be able to block my contents, or don't let the others see what I think they should see. Okay. So we're gonna call, so MOM is the acronym of the standard. It is meant to be a standard to create your very own public, always updated, unstoppable, verifiable message board. So essentially how it works. There are two main parts of the standard. The first one is the part on the blockchain. Essentially an ordered list of messages. To achieve that, you can create a message, create an hash corresponding to that content, and then you can create what I call a MOM payload. So essentially an operation code plus parameters refer to that specific operation code, and you send a self-signed transaction to yourself with that payload. In this way, you fill essentially the blockchain with a list of operation, and oops, I think And the other client can read this operation and create a local index of your updated messages. This kind of operation can be done in a very, very easy way, and they are very cheap. So essentially, if you think that the base transaction is 21,000 gas, you had only, for example, for an add operation with the SHA-256 multi-hash, you had only 548 gas. So it's less than 3% of the gas on top of a basic transaction. So it's really cheap. And this is intended. The second part of the protocol states that you essentially need to store, if you want, the content in some persistent service where you can then lead your users to get the content from. So I suggest use content addressable network like IPFS or Swarm, but because the client knows the hash of the content, you can share with them the content with any other services, even centralized one like AWS S3 or OneDrive and so on. So this is important to understand that the real content is not inside the blockchain. Here you can see a summary of the specification that you can read in fully on GitHub. But essentially, I want to mention the data structure that you can see here. The address that you send the transaction to must be the same as the sign as you, essentially. So this is a self-transaction. It must be zero-way. This is important because this standard must be simple and must avoid as much as possible scams that can lead you to think that you are sending some money to yourself. So it's not a problem, but so it's good to have this kind of constraint. And the data is at least 2 bytes because the first one is the operation code, the second one can be parameters, and the raw option is the least expensive one, but it's not, it's particular. Then we will talk then about that. So this is a very simple, data structure, and it is intended, and it is intended that any transaction that don't strictly adhere to this constraint is considered invalid. Okay. The content part we go that later, but essentially you have 2 kind of commands: the core commands and the extended commands. This is done because the specification wants to be as easy to implement, so you can implement the core commands and release your client, and then you can add extended command later, for example. And here you can see the basic functionality that you can imagine when you share some messages. So you can add some content, you can update some content, you can reply to content of other, and you can delete some content. Obviously, you are not really deleting anything from the blockchain, but you are essentially saying that the index must be delete this kind of information. And the last, another command that I think it's really important is the close count, because this is a standard that is meant to be safe to use for you to communicate with your audience. So if for some reason your private key is leaked, or you think that your private key is somewhat compromised, you need to have some switch off function that says to others, I don't trust anymore this kind of account, please stop and maybe use another. Okay, so the client must ignore any other operation that comes after this command. So it's one-time command. And the raw operation, it's because maybe you don't want to use this kind of content type. To keep it simple and to have something that works from the beginning, I choose to set the content to that the multi-hash refer to be a markdown text in UTF-8 without byte order mask, and so the client must support at least this kind of media type. So for the first version, maybe you want to share something that is not in this kind of content, so you must use this operation for now, and you need to provide to your customer, to your users, the meaning of that hash. Okay, in the version 2 of the standard, I thought to introduce a smart contract that let you define the new content type and new operations of the meaning of the operation. But in the first place, you need to stick to this specification. And the extended commands are for what can be seen as the beginning of something that is more social. So you start giving, for example, endorsement to other messages. So you read something that you find useful and you endorse that content, or you can obviously remove that endorsement, or you can endorse and reply to those to that message, for example. And these two are the only commands that refer also to addresses. So this is because while developing this kind of standard, I felt that the need to talk with someone that I don't know, but I find, for example, some smart contracts that are wrong, or some others that acts in some strange behavior, and I want to talk with them in some way, and currently I cannot do that. So this is a way to say, hey, if you are listening to this kind of standard, and I can send a message and you can respond, maybe not necessarily on the blockchain. This is the summary, and here you can see an example of a payload where you can see the first byte is the command, and the rest is the multi-hash. Multi-hash is very useful in this case because you don't need to stick with a single hashing function, but you can do it dynamically. And these 2 bytes essentially are saying this is a SHA-256 hashing algorithm, and the hash is 32 bytes. So you can read the other 30 bytes and you have the hash of the content. And this is useful for many things. So all the parameters are multi-hashes. So now I want to show you essentially what I created for developers to implement the standard. They are 2 repositories on GitHub, and so you can use it also locally. Okay, this is the client, and the client uses what is already a package in npm and in git packages, so you can use it already. It is already in version 1, so it's fully implemented. So here the package, you have the test for all the cases, and if all goes wrong, yes. Oh, okay. It's all the functions are implemented in the package to create the payload. Instead, in the client, I have also yet some function to implement, but I want to show you the basic functionality. So you have a very, I'm not a designer, so this is a very basic implementation, but essentially I have, I'm running 2 nodes. One IPFS in local and one get in girly network. And it is very important to use your own notes, please. And so you can see here that I'm connected to that, and you can change settings and so on. But what is important here is that you have an operation list and a message list. So here the client has already scanned my my transactions that you can see on the girly network here. So as you can see, it is kind of already recognized in some way these kind of transactions. So the step to implement this specification is really fast. And here you can see the various the different operation that I've done in this network. So because there is not a smart contract to implement this kind of standard, you can use it already in any kind of network. So you can switch between main network, girly, Covan, and so on without any problem. And here, for example, you can create a message. And when you publish this, you essentially put this on IPFS. In my case, my client uses IPFS because Swarm in this moment is not ready for this. Maybe if you want, I can explain why later. So I put this on IPFS, and then I can send the transaction. Okay. Okay, and so I can see here that the transaction is waiting, and when it's done, I will have my message in the message list. So I can essentially do this, and I can modify, for example, the current message. And buy, I think it was 3 buy. So I can see this. And I publish an update. So again, it's on the IPFS, and I can send a transaction okay, to update that content also. So this is the idea, and this is already working. I need to implement essentially the reply, and then all the main features are completed. And this is also just sorry, this window is away, and these also support different accounts. So if I switch the account or the network, the client already knows that. And so I still need to implement the dynamic loading of this, but okay. So here you can see that my messages are now updated. So everyone can see that I want to share this kind of messages, and to check, they only need to find in some way. In these cases, it's very common to share with IPFS or Swarm, so I can search there. And here you can find, again, messages from others, for example, or I can simply, oops, also cut and paste in this case. If this is not my, this is not my message, I can get the ID from any other sources and ask to download that content, so I can see here that the content is downloaded correctly. So just think I'm in time. So what's next? This is not still the version 1 of the client, but I try to work on that in my spare time, so it's not fast, but I'll complete in sooner or later. And this is what I think can be a roadmap for this kind of project. So the version 1, I'd like to see approved, because I think it's very useful and easy to implement in the first place. The next step, I'd like to send a PR to MetaMask, so it's even easier for users to send these kind of messages. And having this on wallets it's really, really useful in this case. And the real turning point, I think, is if some explorer, in particular, I think Etherscan is the best explorer we have in the Ethereum community now, can support this kind of standard. I think the step is really easy to do. So using Discourse is it's not really a good way, in my opinion, to share messages around the community. So if they can get this, I'll be very, very happy. And the last one, and I hope can do this here, is a bit complex EIP for change the way the events are managed in the currently, because we have, I think we have some problem with the events. Maybe I can talk later, but what we lack essentially is events for addresses. So now I cannot listen easily listen to something really easy that sounds really easy. So how many transactions an account is doing, or if someone sends money to some other, I cannot listen to them. I need to create another program that reads the client constantly, and then create something separate from the index of the client. This is because essentially it's storage consuming, this kind of operation. So I hope that I can find some way to create this improvement, and then let the user enable that with the flag. Okay, so if you want to index some transaction from some address, you can do it inside the client and not in another program outside. And the last thing is, if all this goes well, the next step will be to have a smart contract that let you define what, the meaning of that commands, and define the media type you support. So this now the standard is forced by the consensus. So everyone need to agree what that specific command means, and everyone need to agree on the content, in particular Markdown, for example. In the step 2, you don't need to agree, because you are choosing your commands and you are choosing your content. So if I want to read your messages, I must adhere to your standard, not the common one. Okay, so this is a bit more complicated, not so complicated, but a bit more complicated. So I prefer to separate the two steps. And I think, okay, I'm done. I hope I am in time, and sorry for my English. I'm not English native, so I hope you understand what I said. Okay.
You've been doing pretty good with English. Don't worry.
Okay, thank you. So this is the AMA moment. So this is a very kind word in Italian, because it means love. And so I prepared some question and answer that I gathered in these weeks. So if you want, I can go with that.
Whichever you would prefer. We could ask you a few questions if you'd like, or if you have sort of like an FAQ Q&A that you'd rather go through to make sure there's certain basic questions you want to cover, I'd say whatever you like. Okay,
so if I have time, okay, I show you what I gathered. And this is maybe something that Pooja asked me. I think it's one of her questions. So why moving to the next stage now? I think because it's easy to implement in many different languages. I think that is we will have an immediate benefit for the community. The technology is already there, so you don't need to invent anything complex. And because decentralized finance is coming, it's rushing, and scams again becomes more and more common. I think that we need an easy and efficient method to verify who save what. Okay, and also you can create a lot of memes about mom. So I think that it's a funny name. It's a good reason to move to the approved stage.
Memes are always an excellent reason.
And why a question that I received often is why not using a smart contract? I think because essentially you don't need that in this case, because you already have the information when you send the transaction. So a smart contract in this case adds only a cost in gas that is not needed. So sending transactions is very, very much cheaper. So if you need only to set a state and you don't need to do anything with that state, you don't need a smart contract. Many developer creates, for example, smart contract that sends all just events, for example. Even that, I think it's not efficient because again, you send a transaction in the blockchain and you fire again the same exact data, so you are duplicating data inside the recipient. So I don't think it's an efficient way to do that. So yeah, and also you cannot do mistake, because if you have a smart contract, you need to trust that address. So someone needs to tell you that is the smart contract you need to call, and everyone needs to point to the right smart contract. In this case, you cannot do mistakes because there is no smart contract. You read exactly the transaction from that address that goes to the same address with 0 way. So no way to do mistakes in that kind. And again, I already said that with the smart contract will come in the version 2, but not for storing messages. And another question that I have come through is the batches. So it sounds very inefficient to store a single hash for a single message. So someone says, why don't you store a batch of messages? It is a quite not so easy to respond, but essentially, if I use batches, I need to give a structure to the content. If I give a structure to the content, it means that the client cannot understand the state of my board without downloading the content. Okay, so it's not a good way to do it, because you can create loops, so I can continue to download the things and never reaching a final state. And I'm forced to download the content to understand the state. So this is not what I want to do. And so this is the reason why all the information that you find on the blockchain must be enough to understand the state of your message board. And this is why you can send only one message. Okay, this is not meant anyway to be a chat system like Telegram or WhatsApp or whatever. It meant more like a blog or something that you share that has value, because you are paying for that message. It's really likely that that message has some value in there. Okay, so it's not meant to be ephemeral messages that you can send with other chatting system and so on. And that's it. So that was the questions and answers that I created for you.
Do you have time for us to ask you a few questions?
Yeah.
Oh, great.
Sure.
Well, actually, it's very nice that you ended with that line, use only nodes under your control. Before also you talked about the importance of running your own node. Is that also necessary for EIP-2848, or are you saying that as a general security concern? Or maybe I'll even speak that out a bit more. If I'm using Infura or something like that, and I send a message using Mom, does that mean that Infura is able to read the message since I'm submitting the transaction through their node? Also, is there a problem with exit nodes, as in the node that the message is coming off of, that a recipient is reading it off of?
There's not really security issue here because you are only sending some transaction that is signed by you and is as a specific nonce. So the bad things that can happen is that they don't relay your message. That's it. So if you see that those services, that service in particular, Infura or other service, don't relay your transaction, you can simply send with another node. So I don't see many security constraint here. And also, you are not sending, again, value with that transaction, and you are sending to yourself. So it's very difficult to scam you to send something or to do more than just not relaying your message. So in this case, I think it's you can send that message through Infura. You should not read that kind of information through Infura, not because of them, they are for sure a good person, but you should not use third-party services to read from the blockchain. It's not real useful to do that, because if you trust a third-party services, fine, trust them and use them. No, you don't need to have this kind of standard. So you can continue to use Facebook, Twitter, Medium, and so on. And you can continue to ask yourself, I'm seeing what the others see. I'm reading this exact same article that the others are reading, or Medium or Facebook is showing me a specific content that the other don't see. This is a question I don't want to continue to ask me. So
I understand.
Okay, I hope I responded to your question.
Absolutely.
Thanks.
Okay. So have you ever programmed before with with React?
React, no. I programmed with Angular, and in this case, I used Knockout.
Okay. I'm just wondering, like, have you ever? Because this sounds interesting to me in the sense. Have you ever considered using this kind of messaging framework as a means of state management in Ethereum contracts? State management being analogous to, like in React, you have Redux, or in Angular, you have some sort of state management system where you can, keep track of the state of things and update them via like an API or server. And so, because what it sounds like to me is that you're saying you're going to send messages that are going to be saved on the blockchain, and so you could use the blockchain history as a state management tool. Have you ever considered that?
Yeah, you can definitely do that. I think that I don't know React, but there are many messaging systems and state management systems. So the only problem with that it's that they are not meant probably to be used with this kind of architecture to the blockchain. So in the blockchain, you have to pay for transaction, you have to wait for the consensus to reach consensus to have a final state of your application. So I don't think that using that kind of method matches the needs of this use case. So I think that when I use, for example, a decentralized app, I want everything goes fast, and so I can change my UI. I can do a lot of things very fast. And then when I come to an agreement, I need to save something. So I send a transaction that is a slow process. So I think that using the state of React, for example, it's more, sorry. No, grazie. Sorry.
Oh, that's okay. Thank you so much. I think that your points make sense. And my question was also kind of broad in the sense of because I think that, you know, small focused solutions such as Mom, you know, often have side effects. And so I was just wondering if you had ever thought about that sort of an implication in any case. So I appreciate your feedback.
Yes. What side effect do you think can be?
Well, I mean, I don't know too well, but so basically in general, it would just be a similar functionality to state management, except for the full, because if you're sending a message, which is just in general a string, that's the same thing as every other state management system. And so then you could use the blockchain. I mean, this is just a random idea, but I was just interested to see if you, I guess that the broader question was, do you consider this application, you know, further than just say messaging on a message board, or could it be applied to other needs as well?
Yeah, I think that this can be the starting point to have something that can really lead a new way to share content. Okay, so aside by the state management, again, I think it's something really useful for applications, and I think that we lack, we don't have a way to share knowledge in general that is safe, and so this can be a starting point. But I don't want to go too further with the specification and so on, because it's really hard enough. Also with this kind of few comments and many questions arises about why this should be helpful in some way. So thinking about a broader scenario, it's very difficult to explain for me, at least, because to do this kind of thing, you need to do in English. You need to explain your idea. I think that this is not a small point, because, for example, in remaining in the IP topic, many people comes to me saying that they don't understand what I was reading, what I was writing in the EIP. So I try to add more and more information, and this is very difficult to spread an idea not using your own language. And so this is why I prefer to start small. I have other ideas of how this can be grow. This kind of standard can grow, but I'm not prepared enough to explain well in English. Sorry.
I think you're doing a really good job. And I also really think all projects, even those in your native language, should be done focused like you're doing. So I think you're doing fabulous work. Good job.
And maybe if I could ask one last technical question. We've seen messaging protocols on Ethereum before. There's Whisper, which then turned into Waku. Then there was Swarm's PSS prototype. How would you compare and contrast MOM to those two systems, to Waku and to PSS? Like, what would you say the trade-offs are?
Yes, what you mentioned are what I call ephemeral messaging system. So they are meant to replace some chatting system like WhatsApp, Telegram, and so on. So this is not a standard that is opposed to this kind of messaging system. I used message because as a word because of the tone of my own messages, but this is another good question because many people ask me. We can send messages with other techniques, so I don't want to send a message. Essentially, I want to write a message. So the transport part is not in this standard. Instead, what you have said, the application you have mentioned are for transporting the message and chatting. Okay, so here I want only to be sure that that kind of information, that piece of information is sent by me, and I agree with that information, and that's it. So the transport part, it's not in the standard, and yeah, so it's more like a blog system. So blog, it's sound like a legacy word, like a boomer word. So
So what you're saying is that Waku and PSS both talk about implementing their own communications layer, whereas you're leveraging what already exists in the Ethereum system itself without making a new transport, but also that Waku and PSS both have ephemeral messaging, whereas your messaging is not meant to be ephemeral. Is that correct?
Yeah.
Great. All right.
So I may have a question for you that is coming from, I think, your roadmap slide. When we say that this MOM protocol is all about, sending messages and verifying that it is sent by an authenticated user, stored message hashes, is it something that could be used for Ethereum 2.0 chain as well? Like I heard this question in some of the meetings, like people are looking for an application where if a nodes go down, the client may be able to, notify the person, the account holder that your node is down for this much period and you may be slashed, or kind of provide warning messages. What do you think about it? How this proposal, I mean, if at all, how it can be helpful?
So yes, I don't think that this will save you from the slash because if you are validator, I think you will slash it anyway. But there is a problem with this kind of use case because this standard is meant for account. Node have their own identity as a node and as a Ethereum client. So this can at most represent the validator, not the client itself. So I don't think this will be helpful in this kind of scenario. Maybe something like Whisper, it's really more in topic for this kind of thing. And maybe Ethereum 2.0 can bring us essentially can let you send more my own messages with for a few Ethereum, so you pay less. But I don't think that there are many use cases for.
Got it.
Another point I want to address, if I have just a few minutes also, it's this standard is not meant to identify people. So it's really important. It's not an identification system because I only want to know that the author or the owner of a contract, for example, is who is sending that message. I don't care if the author is John, Paul, or Laura. I don't know. So this is not a way to identify people. It's a way to identify who says something in a that currently you cannot do that, because it is true you can sign messages with the classical sign method in Ethereum, and you can, for example, publish that message on Facebook. Okay, but that message you are not sure that is updated. So it's really important, because once you have sent that message out in the world, anyone can say that that message came from you, and it's true, but they can say you sent them that message in that moment. So let's say I say, okay, I agree with you, okay, and I sign this kind of message, I'm done. So everyone can go around and say that I agree with them in any case. So it's really important to have an order, and so you cannot do that in this moment. So it's
I'm so loving this conversation, but there's so much to talk, and our time is up. So thank you so much for joining and sharing it with us, and William and Alita for making this session even more interesting with your questions. I hope our viewers must have gotten many of their questions answered, but if you still have any, please write it down in the comment section below. For those who have joined for the first time, make sure to subscribe the Ethereum Cat Herders YouTube channel. If you have any proposal that you would like to know more, please leave a comment below and we will reach out to the author. Peep and EIP is a relatively new series, and that we have started to share more information on the proposal that Ethereum has. We need your love, your support. So please spread word around, and do watch our earlier episodes. If you like it, give it a thumbs up. If you don't, let us know what you would like to be included. For this episode, the slides that were shared by the author and the contact details will be available in the description section. Thank you all for tuning in. See you with another proposal in Peep and EIP. Till then, stay safe. Thank you, everyone. Thank you, guys.
Bye.
Pleasure.